This is the second part of the discussions on dummy variables. In this module, we will begin with a dummy variable model where both the slope and the intercept of the regression will be affected. So, our regression is y I is equal to say beta 1 plus beta 2 x I plus u I. For example, this might be consumption, and this might be income. Or this might be saving, this might be income. So, we are trying to see the relation between income and saving or income and consumption. Now, this relation may be affected by war. So, there are two possibilities, one is peacetime, the second is wartime. Accordingly, the relationship between income and saving or the relation between consumption and income and consumption might get affected. And if we just draw a simple relation between income and saving, maybe we get a regression like that, or income and consumption also a straight line like that. Say this is consumption and this is income, and so we get a regression line like that. These lines might be affected depending on whether it is peacetime or it is wartime. So, how do we incorporate these qualitative variables? This is a qualitative variable. The political regime or the regime is a qualitative variable because it is either war or peace. So, to incorporate that, we rewrite the model in the following way. We can write y I is equal to beta 1 plus beta 2 x I plus beta 3 d I plus beta 4 d I x I plus u I. And d is the dummy variable which can be used to differentiate between war and peacetime. So, for peacetime, dummy variable d takes the value 0, for war time this takes the value 1. What is the implication of this model? If d is equal to 0, then for peacetime y I is equal to beta 1 plus beta 2 x I plus u I, that is for peacetime. But when it is war, so d takes the value 1. Once again you will note that this is a qualitative explanatory variable which can take which can give two outcomes, that is there are two possibilities. However, we are representing it with one dummy variable. So, we are not writing two dummy variables, one for war, one for peace. We are writing one dummy variable which can take two values 1 or 0, because we have an intercept in the model. As earlier studied, with an intercept for each qualitative variable we take as many number of dummies as 1 less than the number of categories. So, 1 less than 2 is 1. So, for what time we will have y I is equal to beta 1 plus, over here we have beta 3 plus beta 2 plus beta 4 x I plus u I. So, that is war time. So, by now you will have noticed that both the intercept and the slope can be different according as it is peace or war. So, if we concentrate on the regression of consumption over income, then we would get two different regression lines. You can see that the two intercepts are different and the two slopes are also different. Of course, this is not the only possibility. We can have, this is the peace time, that can be war time. So, there can be different possibilities. This is income and that is consumption. So, I am just writing peace and war, and maybe this is peace and this is war. So, this is one simple example where dummy variable can show a change in both the intercept and the slope. Now, this is a very interesting model because it helps us to test whether there is a difference in the intercept as well as a difference in the slope. Let us see how to test whether the two regressions are different. So, viewers will recall that in a general model, the general format of the model y I is equal to beta 1 plus beta 2 x 2 I. This is x 2 just to keep parity with beta 2. There is nothing sacrosanct about x 2. You could have written x I also. Just because I am writing beta 2, I am writing here x 2 plus beta 3 x 3 I plus beta 4 x 4 I plus u I. So, this is a multiple linear regression model with x 2, x 3, x 4, 3 quantitative variables and x 1 implicit in the intercept. So, this x 1 is always 1. And remember, we had used tests like this h naught, say beta 2 equal to beta 3 equal to 0, or we can write this as beta 2 beta 3 is equal to 0 0. So, that is your null hypothesis, and the alternative hypothesis would be h 1 not both beta 2 and beta 3 equal to 0. That means, you write it, that is the beauty of using vector. So, beta 2 beta 3, that vector is not a null vector, and you can test this by running two regressions. One is the restricted model, the other is the unrestricted model. So, this is the unrestricted model, and if we put beta 2 and beta 3 both equal to 0, that means, if we eliminate this and run a regression, that becomes a restricted model, and we use the familiar F statistic to test. The same procedure, dear viewers, we will now apply for the dummy variable model, where we had incorporated peace time and war time. So, beta 1 plus beta 2 x I plus beta 3 d I plus beta 4 di xi plus ui. This is very similar to the model that I just wrote. So, here if we say that there is no difference between the regressions or no difference between the relation of income and consumption during the wartime and the peacetime, that would be saying that this beta 3 is equal to 0 and this beta 4 equal to 0. So, we can test H naught, beta 3, beta 4 both equal to 0 against H 1, beta 3, beta 4 not equal to 0, and this is now our unrestricted model. Whereas the restricted model, what is the restriction? Beta 3 and beta 4 are 0. So, there are two restrictions. So, the restricted model would be yi is equal to beta 1 plus beta 2 xi plus ui. So, that is the restricted model. From the restricted model, we calculate the restricted residual sum of squares. From the unrestricted model, we calculate the unrestricted residual sum of squares. And how many restrictions do we have? We have two restrictions, beta 3, beta 4 equal to 0, and I runs from 1 to up to n. So, there are n observations in totality. So, what we can now do is we can write restricted residual sum of squares minus unrestricted residual sum of squares divided by q number of restrictions. And what is q? Q is 2 here, divided by unrestricted residual sum of squares upon n minus k. That follows f with 2 and n minus k degrees of freedom. And what is k here? 1, 2, 3, 4. So, k here is 4, maybe n is 50 or something like that. And we will reject the null hypothesis. We will reject this if f calculated exceeds the f critical value at the given level of significance. Now, that means we will, if we reject this, that means beta 3 and beta 4, if we reject the null, that means beta 3 and beta 4 are not both equal to 0. That really means that we have two different regressions, one for the peacetime, the other for the wartime. Just as we had shown a few minutes earlier, during the peacetime, it would be expectation y given d equal to 0, that is equal to beta 1 plus beta 2 xi, and during wartime, so that is peacetime, and this would be y given d equal to 1, that is equal to beta 1 plus beta 3 and plus beta 2 plus beta 4 xi. So, you can see that the differential impact of war on the intercept is beta 3 and the differential impact of war on the slope is beta 4. Next, we will look at a special kind of effect called dummy interaction effect. Viewers, now let us take a look at dummy variable interaction effect. So, let us take an example where variable y is affected by maybe gender, which is male or female, also maybe by race, which could be maybe colored and not colored, and maybe by experience. So, this is a quantitative variable. You will have noted that gender and race are qualitative variables and experience is a quantitative variable. Now, if the model has an intercept, then for gender we will have one dummy, say D2, which is 0 for male and 1 for female. Similarly, you will have 0 for colored and 1 for not colored, that is another dummy, say D3. So, D2 is the dummy for gender, which can take value, which will take value 0 if it is a male and 1 if it is a female. Similarly, D3 is the dummy for race. There are 2 categories, 1 dummy, 2 categories, 1 dummy, 1 qualitative variable gender with 2 categories, therefore 1 dummy, another qualitative variable race with 2 categories, therefore 1 dummy, and this will be the variable x. Now, in a model with intercept, when we have D2 equal to 1, then we will have the differential effect of being a female. Similarly, if we have D3 equal to 1, we will get the differential effect of being not a colored person. But the differential effect of not being a colored person may also depend on whether the person is a male or a female. If there is racial discrimination, then the differential impact of being not colored or the differential impact of being colored, that will be conditioned by gender discrimination also, that is whether the person is a male or a female. So, how do we take into account that interaction? That is captured by a model which is called dummy variable interaction effect model. So, let us write the equation y I is equal to alpha 1, we could have written beta 1, I am just writing alpha 1 just to bring in some variety, plus alpha 2 D2I, that D2 will be 1 only if the person is a female, plus alpha 3 D3I, that D3 will be 1 only if the person is not colored, plus I am keeping a gap here deliberately, plus beta times xi plus ui. So, if this were our model, just mentally overlook this gap here. So, if this is our model, what does the model say? That alpha 2 is the differential impact of being a female, alpha 3 is the differential impact of being not colored, and this is the impact of years of experience, maybe this is salary, y is say salary. So, someone might say that the differential impact of being colored will depend on whether the person is a male or a female. That is why we bring in another expression here, which is the product of D2I, D3I. So, when both D2 and D3I are 1, that is when female and not colored, that has a separate effect. So, this is basically the dummy variable interaction effect, that is the additional impact, additional increment, additional differential effect that is occurring for non-colored males. So, this is another particular use of the dummy variable model, and we can test whether alpha 2 is equal to 0, alpha 3 is equal to 0, alpha 4 is equal to 0. So, that would be, that testing would be through restricted and unrestricted model. So, if you put these 3 equal to 0, it will just be alpha 1 plus beta x, and if you put not equal to 0, then you would get the unrestricted model, and you can use the F test as we have already done. Now, having discussed up till now, we will bring in a term called structural change. Structural change, because oftentimes students come across this term structural change in an economy, and dummy variables are used to study whether there is a structural change in the economy. But you will have already noticed that we have done this in the form of different intercepts, different slopes, and different intercept and different slopes. So, these were covered in module 32, different intercepts, different slopes, and both different intercept and different slope has been covered in this module. So, together these three possibilities are called possibilities of structural change, and therefore, we have already actually used dummy variables to study structural change. The last thing that we will discuss in this module is how to capture seasonal effects. So, we have summer, winter, spring, autumn, and you can put D, dummy 2, dummy 3, dummy 4. So, this will be 1 if it is winter, 0 otherwise. This will be 1 if it is spring, 0 otherwise, it will be 1 if it is autumn, 0 otherwise. And summer, of course, we are not going to bring in, because if we have a intercept in the model, we will write y I is equal to beta 1 plus beta 2 d 2 I plus beta 3 d 3 I plus beta 4 d 4 I plus u I. So, better to write D2 here. D2 is winter, that is equal to 1, otherwise 0. Similarly, D3 is spring equal to 1, otherwise 0. D4 is autumn equal to 1, otherwise 0. So, what does beta 1 tell us? It tells us the effect. Say this is sales of Y, could be sales of refrigerators. So, sales of refrigerators. So, sales of refrigerators could be affected by the season in the year, during the year. So, during summer it is beta 1. If it is winter, then beta 2 is the additional effect. So, during winter what is the total effect? Beta 1 plus beta 2. But what is the incremental effect? Beta 2. Or if it is spring, then what is the total effect? Beta 1 plus beta 3. What is the incremental effect? Only beta 3. If it is autumn, what is the total effect? Beta 1 plus beta 4. What is the incremental effect? Beta 4. And if you want to bring in 4 dummy variables, then you can bring in this D1 for summer. So, you can write beta 1 D1. But now you do not have any intercept. So, to avoid the dummy variable trap, 2 things could be done, either intercept and 3 possibilities, so 3 dummies out of 4 possibilities, or you can bring in this dummy variable D1I. So, that, my dear viewers, was the final point that we discussed on dummy variables, and the study material has already been given to you. It is a much more detailed study material, and a PowerPoint has also been given. So, do go through the study material in PowerPoint and get back to us with whatever queries you have. We will be happy to help you. Thank you so much.